In this question, we have a square which has 1 meter on each side. So this 1 meter. And we have point charges of 4 microcoulombs, and they are in two diagonally opposite corners. So they're not telling us exactly where. So let's just say here we have positive 4 microcoulombs, and then diagonally opposite is the other positive 4 microcoulombs. In the other two corners are charges point +3 and -3. So let's say this one is our -3. Again, they are not specifying exactly which corner, and this is +3. What is the potential at the midpoint of the square? So this is asking for potential, which is the V value. So remember, V is K Q over R. Q is not absolute value and V is a scalar. So we had to look at the midpoint. So midpoint is here. Because this is a square, what you have is 0.5 meters here and 0.5 meters here. So what is the R value? The R value is the distance. So let's say this is point Q at the midpoint, from point Q to each of these charges. So let's say the +3 charge, so that would be this distance is our R. And because this is a square, that R value is the same for each of these charges. So now if we look at V at Q position, let's go around the square starting from the +4 microcoulombs. So we have K, and then we have +4 microcoulombs, so that's 10 to the -6. This is in coulombs, divided by R value. Now how do we find the R value? So we know that this is also 0.5 meters. So this is a little right angle triangle we have. So from the Pythagorean theorem, we have R squared, which is 0.5 squared plus 0.5 squared. So R value is the square root of this, and then it turns out it is about 0.71 meters. So that is what we write here, 0.71 meters, and that's the R value. The R value is the value between the point you want to find the potential and the actual charge. So then let's move on to the +3 charge. So that's K times 3 divided by R. R value is the same because this is a square. If it's not a square, the R value is not the same. Let's move on to the other +4 charge. Here is 0.71. And then finally, we are at the other diagonal. We add K, not absolute value, so we retain the negative sign, divided by 0.71. Now something easy to do here, so this is our VQ, is to look at what is common in all of these. K is common, 10 to the -6 is common, and 0.71 is common. This is important to do so you don't spend a lot of time plugging in these values in your calculators, because sometimes things cancel out. So what is here? So we have, from the first one, we have 4. So that's this 4 here. And then we have +3, +4, -3. And as you can see, the +3 and the -3 cancel out. So what you have is K times 10 to the -6 times 4 plus 4 is 8, divided by 0.71. And that turns out to be 1.01 times 10 to the 5th volts, and that is the potential at the midpoint of this square.